I'm going to break down this entire thing. It's a definition for a truth functional proposition. A truth functional proposition is one where the individual truth values forming the compound proposition via the connective are sufficient individually for knowing the truth value of the compound proposition. So what I'm going to do in this video is tell you what individual truth values are. I'm going to tell you what the compound proposition is. I'm going to tell you what the connective is. I'm going to tell you what the truth value of the compound proposition is. And then we'll be able to understand what the truth functional proposition is. So that's what we're going to go over slowly. So first, what's a proposition? A proposition is a statement that can be true or false. So here are examples of propositions. 6 times 5 is 30. So proposition P, which is that 6 times 5 is 30, is either true or it's false. Proposition Q represents I am 30 years old. That's either true or it's false. Like right now as I'm talking, I really am 30. So when I say I am 30 years old, it's true. Proposition R is she's dressed like Princess Leia. Either she is or she's not, right? So these propositions, proposition P, proposition Q, proposition R, they're either true or they're false. Here are examples of statements, you might say, but these are not going to be called propositions. Things like run. Another example might be pass that book to me. Another example is, am I entertaining? These three are not able to be true or false. It's not that run is true or run is false. 5 times 6 is 30. That could be true. That could be false. So these are propositions are statements that can be true or false. Non-propositions are not statements that could be true or false. So we are going to talk about a specific kind of proposition, and then we're going to talk about the truth functional proposition. So here's something we also need to know. The law of excluded middle says that there are propositions which are true, and there are propositions which are false, but there are no propositions which are both true and false or neither true nor false. So the law of excluded middle, it says, and this is just something you have to agree with, like the law of gravity, it applies no matter what, within logic. The law of excluded middle tells us that a proposition is either true or false. It cannot be both true and false. It cannot be neither true nor false. So there's no middle ground here. Every proposition is either true or false, not both, and definitely one. Let's get a little bit more complicated as we work towards our definition. So we've got these symbols, and here's one symbol. It's something like an and without the line, the letter A for and without the line. And there's also another symbol, dot. That dot, just like that symbol, represent this logical operation of conjunction, which is represented with this concept in English, and. This one, it's a V, which stands for vel, is the Latin or. The V is a symbol which represents the logical operation of disjunction. So let's have some examples. If I said P or T, P is a statement that can be true or false. Here's an example. What does it say? Plant is alive. So let the plant be alive, the plant is alive, be represented as proposition P, and let this proposition, you are in trouble, be represented by the letter T. So here's a proposition, you are in trouble. Here's a proposition, the plant is alive. And you can put those together and logically represent that as P or T, because that disjunct, that symbol says or. Here it is in English, here it is logically. And now let's do an example with and. So if we had P, that symbol H, maybe P represents that the pizza is here, H represents that I am hungry. Let's continue thinking about this logical representation of the compound idea. What's compounded? The idea that the pizza is here is put together with the idea that I am hungry. So if we want to work towards our definition, let's just consider and, so that we can have an example of a truth functional proposition. P and H is a truth functional proposition, and we're going to figure out what exactly that means. So we have this idea, P, that symbol which is represented by and then that symbol H. Pizza is here, P, and I am hungry, H. Now when we put that together, it's true or it's false that the pizza is here. And it's true or it's false that I am hungry. But there's also true or false that the pizza is here and I am hungry. So notice that you have this atomic idea, P, and you have this atomic idea, H. And if we put those together and connect them with the conjunction of and, you're creating a whole new idea. That whole new idea is called the compound proposition. So it's true that, what am I doing here? This way. So it's true that there's two options for P, for the idea that the pizza is here. The pizza is here or it's not. And H is that I am hungry or I'm not. But when we put those ideas together to create the compound, what we're saying is, in what world is the compound proposition true? There's only one case where P and H is true. And that's the case where P is true and H is true. So if it's true that the pizza is here, and it's true that I am hungry, then it's true that the pizza is here and I am hungry. But in all other cases, for example, if P is false and H is false, then P and H is also false. If it's false that the pizza is here, but it's true that I am hungry, it's still false that the pizza is here and I am hungry. So there's three ways in which P and H could be false, and that's any circumstances where either one of them is false. The only case in which P and H, the compound proposition, is true is when P is true and H is true. So when you get these ideas like P or Q or H, these propositions represented by letters, and you put them together with a connective like and or like or, then you're getting a whole new proposition, a compound proposition, and the truth value of that compound proposition will depend on a putting together of the truth value of whatever is the atomic proposition and whatever is the other atomic proposition. So now we have what it takes to understand what this means. A truth functional proposition is the proposition, the compound proposition, potentially. And how is it a truth functional proposition? It's if the individual proposition and the other individual proposition done the operation that the connective is telling us to do, if you can figure out the truth value of the compound based on those truth values of the individuals. In other words, a proposition is a truth functional proposition if and only if the individual truth values forming the compound proposition via the connective are sufficient for knowing the truth value of the compound proposition.